accounting game night. Okay? There are tables. It is from 6 to 8 p.m. It is to help you study for finals. There will be different tables, okay, activities. Some of it you know, right? You might be like, oh yeah, I know my journal entries or whatever, right? But your final exam is cumulative. It's a department-wide final. Kevin didn't write it. It's a departmental final. It has multiple choice and short answers. The short answers are based on chapters 1 and 2, the journal entries. The multiple choice is comprehensive, 19 through 26, and appendix, whatever you do, C and D, one of those. There is a table, so we have like 5 tables with activities that everyone does because it's all on 1 and 2, or those, it's getting your trial balance in order, it's your journal entries, it's that kind of those, and you can move around those tables. And then there are 3 different stations for each class, and one is for accounting 212. And there will be it will have a screen with multiple choice and going through 30 multiple choice questions, and with a whiteboard going over the answers, why that was the right answer, and that those multiple choice were made to review the multiple choice on your comprehensive final exam. So November 21st, 6 to 8 p.m., I'm providing pizza, okay? Counting game night.
Where is it?
It's, you'll see signs when you come here, but you go through here past the bathrooms. I mean, it's a huge event space over there. I mean, it
in
is
this building.
in this building on the Native American side, yeah, the Indigenous Cultural Center. So you just come in here and walk down this hallway. You'll see. Last year there was almost 100 people there. And in spring. Spring was the first time we ever did it. Who went in spring?
This one.
You went, because you were in 112 then, right? Or were you in
212?
Oh, you were in 212, and you were in 112. Okay, so you'll have different multiple, right? Wasn't it fun? It's going to be different. We've changed it. It's no bingo this time. We're doing a Kahoot.
Ooh.
Prizes from the bookstore, including gift cards, money, so you can go buy SEC swag. You can go, they sell like best-selling novels. You can go use it to buy some Christmas presents or some birthday presents or a book to read yourself over the break. So who's going to accounting game night?
I'll be there.
It really, especially the multiple choice part for the 212 is probably
that's where we're all
the
at.
most part, huh?
He told us that's where we're all family. Like
The multiple choice?
Like we all, I think 92% got like the majority of all the same problems wrong. Or 85%.
Well, and I will tell you, he didn't write the final. So, how's everybody? Hey, where are we at? Chapter 9. Chapter 9.
Hey Sue, you look real small next to him.
Huh?
You look really small next to him.
Oh, I know. He's very tall. What? Yes, makes me feel little. He's very tall. I wonder how tall he is.
He's real tall. I don't know.
He's like close
He's
to
looking at
7 feet, don't you think? He's probably like 6'8". What do you think, 6'6"? No, my daughter dates a boy who's 6'5", and
6'10".
I don't feel like I do that to him. I feel like, I think, I'm gonna ask him, my guess is 6'8".
I don't know, he's tall, that's all I know.
I mean, I think he's pretty, yeah, he's really pretty. Okay, so, let us get a book open. So we were about to start a problem, or am I making that up?
No. Problem 5.
Problem 5? Alright, my memory. Last night I thought, oh, I must, when I have my meeting today, say this, and I can't forever think of what the thing was. So we're going to do a Kahoot at the accounting game night. And I'm like, the last question has got to be blank. And last night I still had this genius idea, and today, the heck, I can't remember what it was. I'm like, maybe was it like, to get them to answer about, I thought maybe it was, like to do an evaluation question, like we would just get the results of like how valuable did you think the night was kind of thing, but it wasn't that. All right, so we're on what, number 5. Oh, it's about the type 1 and type 2 errors. Okay, so just let's refresh then for a minute about what a type 1 and type 2 error is, because I've got a feeling maybe some of you don't remember. Would that be right?
Yeah.
All right, so we'll do a quick review of type 1 and type 2 errors, and then we'll pull up the problem. So to review, okay, so whenever we use statistics, which by definition is based on a sample, there's a chance I can be wrong. It can be a chance that I got a screwy sample and I make the wrong decision. So in hypothesis testing, we have this hypothesis that we're going to test, and in step 7, we make a decision. We're either going to reject our hypothesis or we're not going to reject our hypothesis. One or the other. Whatever I pick, there's a chance I made a mistake. If I decided to reject the null hypothesis, there is a possibility that it is actually true. Even though I threw it out the window, it was actually correct. The chance of doing that is a type 1 error. Okay, a type 1 error is rejecting a null that was true. It happens alpha of the time. You, as the experimenter, scientist, researcher, get to pick alpha. You say, I want to be 95% sure I'm right, then alpha is 5%. Okay, you get to pick what that is. A type 2 error, it can only happen if you decide to accept the null. Okay, so you can't make both mistakes. You can only make one or the other. If you decide to reject the null, you could make a type 1 error. And if you decide to accept the null, you could have made a type 2 error. So you can never make both because you're not going to accept and reject the null, right? So a type 2 error is when you decided to accept the null, but it actually is wrong. That would happen beta of the time. It's a very complicated formula, but and you might learn more about it, especially if you go in upper level finance and stuff. But we're going to avoid it completely by not saying that we accept the null. We're going to use the terms, I do not have enough evidence to reject the null. So I'm not saying that it's right. I'm just saying I don't have enough to reject it. Okay? So if the null is true, and your decision in step 7 is do not reject it, you will be right. And you will be right 1 minus alpha of the time, or whatever your confidence level is. If the null is true, and you made the decision to reject it, you were wrong. You made a type 1 error. And you will do that alpha of the time. So whenever you make a decision, you need to know you might have made the wrong decision. Sometimes you find out you made the wrong decision, and sometimes you don't. If the alternative is true, and you decided to not reject the null, you were wrong. That was a type 2 error. That will happen beta of the time. If the alternative is true and you decide to reject the null, that was the right thing to do. And you would do that 1 minus beta of the time. But you can make yourself always right by saying, I don't have enough evidence to reject the null hypothesis. So we talked, I think, did we talk about this slide? Maybe? Right. And so what we wanted to do was know that if this new system in our cars increased miles per gallon, we wanted to know this, is mu greater than 24? Okay? And the opposite, we had to test the opposite because we can only test equalities. We can't test if something improved or something decreased. It has to have an equality. So we're going to test this. If we reject the null, this one, we're able to reject it. That would support what we believe, right? And so we'd say, okay, I reject the null. This new system in the car works and I get more miles per gallon. I'm going to put this system in all my cars. And then I find out it didn't work. That would be a type 1 error, right? I rejected the null when the null was true. So I rejected the null. I thought it worked. I put this in all my new cars. And then over the long term, I figured out that really I was wrong. That's a type 1 error. Rejecting the null when the null was accurate. Okay. A type 2 error you can only make if you accept the null. If I accept the null, I say, oh, this new system, it doesn't work. So I don't put it in my cars. But a type 2 error is, it actually would have worked if I put it in the cars. But I might never find that out, right? Because if you don't do something, you never find out that it might have worked. So this one, so it depends which way around, right? If I did something, if I put the system in the car and I'd made a mistake, I would find out it didn't improve. Because over the long term, I would figure it out. But when you type this type 2 error, I'm going to not put the new system in, and I would never find out it would have worked if I'd have done it. And so sometimes you find out that you were wrong, and sometimes you don't find out that you were wrong. You just need to be aware whenever you make a decision based on statistics, there is a chance that you're wrong. All right, so we'll go to that question 5 on Duke Energy reported that the cost of electricity for an efficient home in Cincinnati was $104 a month. A researcher believes the cost of electricity in Chicago is higher. They took a sample of homes in Chicago and they wanted to see if the mean monthly cost of electricity, I thought I was going to have to write it down. You have to tell you what it is higher, right? So the researcher thinks the electricity in Chicago is higher. Okay, I want you to do the steps 1, 2, and 3, just to review what we did the other day. So step 1, write down the claim, or what you want to know, what you want to test. Step 2, write down the opposite, so they're mutually exclusive and collectively exhaustive. And step 3, label them. Which one is the null and which one is the alternative? Take a couple minutes and write that down. See if you know how to write that down. I want to know if the mean in Ohio is more than $104. Do you agree? Higher. Greater than. Not the same. Don't put an equality there. Higher. What is the opposite? That doesn't look like a 4. What happened? What is the opposite of that so that they are mutually exclusive and collectively exhaustive? Less than or equal to. Do you agree? Which one's the null? Why step 2? Because it has to have an equality in it. So if you know that, right, I told you on an exam that might help you eliminate 1 or 2 even of the answers as stupid answers. The null hypothesis has to have an equality. So if you see a multiple choice where there's not an equality in the null, you can cross it out without reading the question. And now you're down to a couple answers. Okay, so that's the one what they wanted us to test. Okay. Then A says, assume that the sample data, so right, that's what we're going to learn today. We're going to do steps 4 through 6 today. And then in step 7 is when you make a decision. Okay, so it says assume it said, okay, step 7, you're going to reject the null hypothesis. Okay. What would your conclusion be about the cost of electricity in Chicago? Okay. We decided that we reject the null hypothesis. Then we have got to think the alternative is true. Because if you don't believe the null, The alternative is written so they're mutually exclusive and collectively exhaustive, which means it's got to be one of them. Right? So if we reject this, we must think that this is true. Then if we reject the null, we would believe that the cost of electricity in Chicago is higher. Do you agree? See what they say. Conclude that the population mean monthly cost of electricity in the Chicago neighborhood is greater than 104. What's a type 1 error? When does a type 1 error happen? Type 1 error can only happen if your decision in step 7 was to reject the null hypothesis. We decided to reject the null hypothesis. Okay? We think that Chicago electricity is more than $104. A type 1 error means we're wrong. We rejected a null hypothesis that we shouldn't have. So a type 1 error is rejecting this null hypothesis and believing Chicago's electricity is more than $104 a month when actually it's 104 or lower. So by definition, a type 1 error can only happen when you decide to reject the null. And you reject the null, and by definition, an error means you made a mistake. So you rejected the null, but you shouldn't have. Okay? Type 1 and type 2 errors are going to be just a multiple choice question on the exam. Okay, so a type 1 error is rejecting the null when it's true. The error occurs if the researcher concludes that the mean cost of electricity is greater than 104 when it's actually less than or equal to 104. So a type 2 error can only be made if you accept the null hypotheses as true. Okay, that is, you believe, you do a test and you say, I accept the null hypothesis that the electricity in Chicago is less than or equal to $104. But an error by definition means you're wrong. So you accepted a null when really this was true. So accepting the null, you think that electricity is $104 or less when it's actually more. Okay, so the type 2 error is accepting the null when it's actually false. It occurs if they conclude the mean for Chicago is less than or equal to $104 when it is not. Okay? Does anybody have any questions about type 1 and type 2 errors? You can't make both. You can only make one or the other, and it's dependent on what your decision is in step 7. Okay? Josh says he's the only one who got my Who Shot JR question. I was watching the TV the other day and there was an ad for a movie, and the old man actor was Patrick Duffy, and he was like, I'm like, oh, he was JR's brother. I'm like, oh, flashback to my Who Shot JR, and everyone would be like, who's Patrick Duffy, right? He was one of the main characters on my Dallas show. Isn't that funny? I have a daughter who lives in Dallas now. All right, so now for the tests. Okay. How to do a hypothesis test. There's going to be 3, I told you there's 3 different cases. We're going to do means with z-scores, we're going to do means with t-scores, and we're going to do proportions with z-scores, because we never do proportions with t-scores. Agreed? Else it's a binomial question, remember that? So we have to remember that we have to prove if we want to use a z-score. What is the proof for means? For that I can use a z-score? And greater than or equal to 30? And sigma's given. That's number 2. Underlying population. Bell-shaped, and sigma's given, and number 3, and it's greater than 100. Okay, so we're going to have a proof. And then I told you there's two different methods. They're called the p-value and the critical value method. I'm going to show you both. Your homework, usually like part C will say what are the critical values, and then the last part, like part G, says what's the p-value. On the exam, you're going to have two questions from this chapter. One is going to tell you to use the p-value method, and one is going to tell you to use the critical value method. So you need to know both methods, and every example I do, I always demonstrate both. Okay? And so, and then I said also each question can be a left tail, a right tail, or two tail. That's why there are 3 different cases with 3 different tails with 2 different methods. There are 18 different ways this question can be asked. That's why I'm going to give you the 7-step process to give you some scaffolding, how to scaffold every single type of question. Okay? So today we're going to do means, and we'll probably just get that far. We'll do 1-tailed and 2-tailed means with z-scores. And then next class we'll probably do the means with the t-scores and the proportions. Okay? So the only difference between steps, the critical value method and the p-value method is step 6. Okay, it's the same as, also I want to say, when you do your homework, it doesn't ask for the 7 steps. But if you do all the 7 steps on a piece of paper, you will have the answers to every question they're going to ask you, right? But so set up your scaffolding, because on the exam, I ask for the 7-step process. And if you haven't been doing your homework like that, you haven't done it enough times to remember it. And then I see people write like this, and they kind of blur it all over here because they're not really sure what goes where. I know you really know what doesn't go where, but you don't know what goes where. That's why you write big and hope I can figure it out. All right, so we've done steps 1 through 3, right? We write down the claim. We write down the opposite of the claim so that they're mutually exclusive and collectively exhaustive. And then in step 3, we determine which one is the null and which one is the alternative. Step 4 is easy. Write down alpha. That's why it's only worth 1 point. Right, that's easy. Step 4 is going to be worth 1 point. Write down what alpha is. Step 5 and 6 are the big points. Okay, 7 is a little bit because it's critical thinking. But step 5. Calculate the test statistic. That is, here's this claim that we are going to test, right? They're going to claim Walker's bottle of soda's got 20 ounces or more in it. Okay. Now I go collect data. I go gather my data to test it, right? And I'm going to say, oh, well, I got 19.87 ounces, not 20. So I calculate a z-score for that. Okay, and say, okay, how far away is that? Am I off just a little bit? Because I remember when I take a sample, it's not perfect and it has error attached to it. Or is that difference between what I got and what they claim statistically significantly different enough that I'm able to reject that that's got 20 ounces in, like the cans of tuna example. Okay. So, did I tell you about the tuna? Right. Did I tell you about the baby Ruth? That used to run?
Yes.
The candy ice cream, right? You could do it enough times that you could prove it wrong because it was statistically significantly different enough. So, that's calculate your test statistic. Here's where you have to decide, do you get to use a z-score or do you have to use a t-score? So attached to this is the proof. It has points attached to it on the exam, so make sure you do the proof that you use the right one. In 6, we're going to figure out what is called the critical z-scores. So let's say, for example, with that soda one, where we had this, when we were talking about the 2-liter can of soda, the 2-liter bottle of soda, the manufacturers claimed there was at least 67.6 ounces in the 2-liter bottle of soda, and the opposite was this. Oh, 67.6 ounces. Do you agree? Is this a 1 or a 2-tailed test?
1 tail.
1 tail. Left or right?
Left.
Very good. It's the way the arrow is pointing in the alternative hypothesis, because the manufacturer claims that in the 2-liter bottle of soda, there's 67.6 ounces or more in it, right? And so I can only prove them wrong if I get something less. Do you agree? And so the type of tail, what kind of test it is based on where my rejection region is. Okay, so my rejection region's in the left tail, it's a left tail test. Okay, so that is always associated with a greater than or equal to. A less than or equal to question would be a right tail, and if it just has plain old equals, it's a 2-tailed test. You care if it's less or more. So the critical z-score is, what is the z-score here that cuts off this, that starts my rejection region? What is this? What's the z-score for this? 0, right? And so this is going to have a negative z-score, isn't it? Anything to the left of the mean is a negative. So what is this z-score here that cuts the rejection region off from the do not reject region? That's what the critical z-score is, and that will be based on whatever alpha you pick it to be. And we'll look up some of those later. Okay, but if it was a 2-tailed test, right, so I put all of alpha in here, and then I will go look up in my booklets, right, if this is 0.05, what's that z-score that gives the area to the left of 0.05? We know how to do that. If it was a 2-tailed test, we have to split alpha into 2 tails. This is what we're used to doing in chapter 8 when we made our confidence intervals, right? So this is kind of like making a confidence interval. What are these here? As long as I get something in here, I'm fine. If I get something here or here, because it's got 2 rejection regions, then I'm going to be able to reject the null hypothesis. Okay? So critical z-score is, what is the z-score, or t, when we get to t, that cuts off the rejection regions from the do not reject region. So here, if I did a test and I got 67.7 ounces, I'm like, you're good to go. I don't need to go through steps 4, 5, right? I'm like, oh, it's great. But if I got 67.5 ounces, I need to figure out, is that in here, where I'm suspicious, but I don't have enough evidence beyond a reasonable doubt, or is that down here in my rejection region, right? And that's what we're going to find out by doing our test statistic, right? And our critical z-score. If I find that my critical z-score, and then I get my test statistic in step 7, I get my test statistic and I see, did it fall down here, up here, or here? Where did it fall? The only difference between this critical value method and this p-value method is this step 6, right? So up here, all the same, test statistic. But instead of finding a critical value like I did here, what I'm going to do is, in the p-value is, I'm going to take my test statistic, let's say I got negative 1.7, okay? If that's my test statistic, and it's a left-tailed test, I'm going to find out this area here. I just look it up in my booklet and find out what that area is. That's the probability. That's the p-value, is telling me what's the probability that whatever you got from your data, right, that this happened by chance. Given that the claim is true. Given that the claim is true, that the null hypothesis is true, what's the probability this happened by chance? Okay. That's what the p-value is telling you. What's the probability this happened by chance? And so then, if you do a p-value method, your decision to reject or not reject is whether your p-value is less than or equal to your alpha, okay? And we'll do both of those as we go through. So for your test statistic, okay, if you've proved you can use a z-score, right, one of those 3 things that we talked about, this is your formula for your z-score. It is your sample mean minus your hypothesized mean. So let's say, right, I got 67.5. I would put 67.5 was my sample mean, but they claim they're 67.6. That's my hypothesized mean. And then I divide by the standard deviation over square root of n. This could have attached to it what? The denominator. What could be attached to it? The finite correction factor. But I would tell you from chapter 9 on, I promise there's no finite correction factor. Okay. But you just keep in mind that, that's a standard error, right? So it could have the finite correction factor attached. Okay, if I get to a t-score, right, it's a very similar formula. There is a time when you get to use a z-score, though, that you have s instead of sigma. When is that? When n is greater than 100. Right, but you'll have done your proof, but I didn't want to give you too many formulas. There is a time you have to use a t-score when you have sigma. When what? N is less than 30. If you had n is 25 and sigma, you can't use a z-score, right? So sometimes that's sigma, and sometimes that's s, but not usually. And then this is the proportion one, and we'll do that next class. Okay, so here's a question. The response times for a random sample of 40 medical emergencies were tabulated. Oh, talking about that, did you know that Barbara Gonzalez got injured? Did you hear about that? After she left the conference, her car broke down on the way home, and so she was getting out of the tow truck, and she fell and broke her arm. On Saturday after the conference. Well, they've been at a conference for 13 hours that day. So, yeah, she broke her arm. Because she can't drive to the ACE competition in Tucson next week. Yeah.
Is that a team going?
Yeah, 2, I think.
Oh, wow.
Yeah, she's got to get another driver. Anyway, sorry, that was not talking about medical emergencies that I just heard about today. The sample mean is 13.25 minutes. Hopefully they live in the sticks, because I don't want to wait 13.25 minutes for an ambulance if I go for one. The population standard deviation is 3.2 minutes. The EMS director wants to perform a hypothesis test with a 0.05 level of significance to determine whether the service goal of 12 minutes or less is being achieved. Okay. I'm saying it's looking kind of rough. He wants to make 12 minutes or less. I sampled 40, I got an average of 13.25. It appears that he's not meeting his goal, doesn't it? But is that difference, that 1.25 minute difference, statistically significantly different